Hello. Yes, let me give you some information about matrices. So we're going to talk about addition and subtraction. So the idea is that if you have a matrix, for example, here's one. 1, 2, 3, 4 is one of my matrices. And if I want to add, say, another one, 1, 2, 1, 1. The idea is that when you add them together, what you do is you just add them what we say component-wise. Okay, so I take the 1 and the 1, add those together, I get 2. 2 plus 2 is 4. 3 plus 1 is 4, and 4 plus 1 is 5. So that's sort of how it's done. So we can add and subtract matrices also. So let me do this example here. All right, so I'm going to, let's just perform this. So just so you get the hang of it, you'll have to practice and make sure that you can do this operation. It's just a calculation. I'm going to subtract these here, okay? So I'm looking at this 2 and this 1. So if I take 2 minus 1, I get 1. Okay? If I take 8 minus, notice we're subtracting, 8 minus 3 is 5. Right? That was from here and here. So it's done component-wise, etc., etc., etc. Similarly for, now let's take a look at this next one here. You see, now, one thing about addition of matrices, and this is very critical, is that we have to add the same size matrices together. We cannot add, for example, these two matrices together because they have different sizes. So this thing, they can't be added, okay? So let's do this problem here, see if we really get this. It says, it doesn't say anything, but I'm gonna actually solve this. I'm gonna find S and T, all right, that makes this a true statement. So when we say two matrices are equal to each other, it means that their components are equal. So we must have S minus 4 is equal to 6. We would have to have T plus 2 is equal to 2. We need minus 5 being equal to minus 5. So that's this one's definitely true. And we have to have 7 equal to R. Okay. So if I'm trying to find S and T that make these two matrices the same, the only two equations that I have to solve are these two. Okay, so I'll just take a look at that. Well, you see, this first equation tells us that T has to be equal to 0, right? That's the only way that T plus 2 can be equal to 2. And the first equation here, this one, tells us that we must have S is equal to, well, what is it here? I guess it must be equal to 10, right? 10 minus 4 is 6. So that's just sort of a goofy little exercise to make sure that you understand what it means for two matrices to be equal, and that is that all of their entries are equal. So let me do this little example. Here's an example where we can actually use the language of matrices to describe a situation. So here we go. It says the table below gives the educational attainment of the U.S. population 25 years and older since 1970. The source is the U.S. Census Bureau. Okay, so the first question is, it says, write a matrix for the educational attainment of males. Okay, so all right, so what we might do is the following. We might see where's that information. All right, so it's right here, right? Okay, so we might say, well, all right, so the matrix for what we would write would just be, well, essentially what you see inside that box, right? It would be, I'm just going to sort of start the thing. It would be 55.0. Then in this one we'd have 14.1, you know, dot, 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 and then we'd get, I'm doing this rather quickly because I want these videos to be fairly short, and what you should do is make sure that you understand them completely by either performing the operations that I'm doing in this video completely, and then you can stop and go back and see what's going on. So that would be the matrix for the males, right? If I wanted to write a matrix for the educational attainment of females, essentially what I would do is I would just capture these numbers right here in a matrix. And a matrix, of course, is just an array of numbers with a certain number of rows and a certain number of columns. These two matrices have, let's see, 1, 2, 3, 4, 5 rows and 2 columns, or we would say this is we'd write it as a 5 by 2 matrix, right? Okay. Part C says use the matrices from part A and B to write a matrix showing the difference in the educational attainment between males and females. So for that one, what we would do is if I were to say this is A, the matrix that you're sort of seeing up there, and if this was the matrix B, the difference would be the matrix A minus B, and I'll start writing that right here. So the difference would be, let's see, if I take 55 minus 55.4, I would get a minus 0.4 in the first entry. Then right here, if I took my 14.1 and if I subtracted 8.2, I get something like this, right? What is that? 5.9. Is that right? Yeah, I guess that's right. And et cetera, et cetera, et cetera. So you can express the difference in their educational attainment also in a matrix. And then we need to make sure that we understand what the entries in the matrix mean when we translate them back into the real world for application. So that's in a nutshell how you add and subtract matrices.